welcome and thanks for giving us the opportunity to present our research. I'm going to talk about our dynamic microsimulation model that we're developing at WIFO and how we use it to project future socioeconomic developments by accounting for Lifecourse heterogeneity. Now, our aim here is that we want to produce projections of labor force participation and how the size and the composition of the labor force changes in Austria over time with a very long time horizon. And doing so, we want to account for changing demographics. We want to account for changes in family structures, changes in education structures. We want to account for changing in health status among the population. And we also incorporate institutional settings, especially with respect to the retirement system. And we are going to be fully consistent, reproducing official population projections in our simulation. But we extend these population projections by accounting for education-specific differences in mortality and fertility. And very important, we also want to produce labor force participation projections where we allow individual characteristics to impact on the likelihood of being in the labor force. So we want to account for education, migration background, age, family status, and a wide range of other characteristics to impact on the individual likelihood of being in the labor market. And for us, this model is not only a projection model, but also a policy analysis tool. So we can identify important policy levers that affect labor market careers. And our model also supports scenario-based what-if analysis. So this allows us to simulate how changes affecting specific groups in the population affect overall results. Or we can also simulate how changes in the institutional settings affect our results. The whole model that I show you here is going to be the starting point also for two studies that we perform within our Horizon project, Sustain Well, where we want to go deep into analyzing how detailed modeling of migration, retirement, and pensions affect the sustainability of the welfare states, okay? Or what we think about sustainability. So what we need is modeling labor market careers that also have longitudinal consistency. So we want to have, on the individual level, realistic life courses with respect not only to education, but also when people enter the labor markets, their whole lifetime in employment and retirement decisions. And the idea is the better that we can incorporate all these factors that impact on the labor markets, the better our projections will be in the end and the more useful it will be for policy analysis. Just in a nutshell, at WIFO we are developing two types of microsimulation models. The one is called MicroWelt. This is a comparative international microsimulation model where we use harmonized published data to generate our starting population and to estimate the processes in our model. And then we have MicroDEMS, that's the second one, that's the one I'm going to talk about now. That's a more detailed model that's specific for the Austrian case. And here we also incorporate analysis based on a very rich set of longitudinal data sets. So we exploit whatever data we have for Austria to gain parameters for our model. And both these model types have been used quite successfully in recent projects. So I just put here 5 publications from this year, just to give you an impression of which type of analysis we do and where these models are used at the moment. Now, just to explain the model very briefly, MicroDEMS is a dynamic microsimulation model. We use an interacting population model. So individuals in the population interact with each other. It's operated in continuous time, so everything can happen at any time in the model, and people are linked to their families. So we can allow for parents' characteristics to affect their children. And a really distinguishing factor of our model is that although we're working in continuous time, we can allow for optional alignment to external targets. That means, for example, we can define how the unemployment rate evolves over time in our simulation, and in different scenarios we can change this unemployment rate. And doing so, we preserve the relative differences in the risks based by individual characteristics. So we don't destroy kind of how health or age or education impacts on relative risks. We can preserve this. The model is made in Margin programming language, and our model simulates very detailed biographies, starting from the education system, which depicts the Austrian school system very detailed. We have family formation processes, we model the entire labor market careers, and we have spent a lot of time also thinking about how to model retirement decisions based on these individual labor market careers. And in the base scenario that I'm going to show you here, we basically keep all influential factors on the individual probability of being in the labor market constant, but we will account for changes in retirement age of women, because Austrian pension system law requires that the pension age of women is going to converge to that of men beginning with next year, implying that old age retirement is going to increase by 5 years for women and 4 years for some types of early retirement age. So this we want to incorporate in our model. And a very specific element of the Austrian pension system is that it indeed requires full lifetime accounting. So every month you spend in employment is relevant for qualifying for early retirement and the pension level you receive if you retire. So this requires that we really need to model labor market transitions realistically. And just to give you an impression of the complexity of our labor market model, what you see here is the different labor market states that we distinguish. So people can change from out of the labor market into the labor market. If they're employed, they can choose between different sectors. And all these transitions between these states are estimated based on administrative data sets that covers almost the entire population. And for those people, we can follow the employment careers back to the year 1972. We can add health data, and then we can estimate hazard models that show us how personal characteristics or other characteristics affect the transition rates between these states. Okay? And with respect to pensions, we model all pension types that exist in Austria. We have invalidity pensions, we have 3 different types of early retirement, and we have old age retirement, and we incorporate all cohort-specific retirement rules that are legislated at the moment. So what you see here is how in our base scenario the total number of people in the labor force will change over time. So the black line is here. You see from 2022 onwards, the number of people in the labor force is being quite stable with a slight increase in time. But what changes more strongly is the education composition of the workforce. So what you see above the zero line here, this is people holding academic degrees. The number of these people is going to increase strongly over time, while on the other hand, especially vocational education groups are going to be less present in the labor force participation. So although the overall number of people in the labor market won't change that much, the composition will change a lot. And we could do similar graphs showing how the composition changes with respect to migration background, health status, or other factors, but I just want to show you this one. Nice thing about our model is that we can also explain why things happen in our model. So what you see here is a decomposition of the total change in the labor force between 2 points in time. So I show you here between 2022 and 2040. And if you look only at the age group 60 to 64, we see that the overall number of people in the labor force will increase by 85,000 people. And we can decompose this change, showing what would happen if the labor force participation rates would remain constant. Then we would have a negative effect. So the population effect, so to say, is negative. But we still have an increase because we have these 2 positive effects. And the large one here is the retirement effect that shows how much of the increase in the labor force of the age group 60 to 64 can be contributed to the increase in retirement age over time. And this residual term here, the blue one, is the composition effect that shows how, even if we wouldn't have any change in retirement age, the number of people in the labor force would change. And you see here, this is positive because of education expansion. People enter the labor market later, and they have less time to accumulate the necessary contribution periods to qualify for early retirement, which drives up labor force participation at higher ages. Okay? And here, one last graph shows how the rate of active in the total population is going to change over time according to our baseline scenario. This will go down from 0.52 to 0.47, and the other lines show you alternative scenarios. Okay? The green line down here shows you what would happen if we would keep the labor force participation rates constant, and you see, of course, this implies a much lower rate of active in the population. The black line shows you the baseline scenario, but what would happen if there was no increase in retirement age. So that is what is left over only from the compositional effect of the population. And here on top we have another stylized scenario where we say in the time period 2022 to 2040 we want to halve the gap in the labor force participation rates between people with health impairment and no health impairment. And this would also drive up labor force, the number of active people in the labor force. That's just to illustrate kind of what kind of policies we can simulate here. So to conclude, we have a model that's not only aimed at projecting how the labor force will change over time, but it's meant to be an ex-ante policy tool that empowers us to evaluate how stylized policies would affect diverse socioeconomic outcomes in the medium and the long run. So I will have a break now. Thanks.